Hello everyone. Today we're going to talk about substitution matrices for protein alignments. The first among these is the substitution matrix based on physicochemical properties. And the second one is PAM, point accepted mutation matrix. Third one is block substitution matrix. That is nothing but BLOSSUM. In this lecture, we are going to talk about in detail about all these three kinds of matrices. Substitution matrix based on physicochemical properties is a matrix that is basically based on properties like polarity, size, charge, hydrophobicity. Whereas if you are talking about PAM and BLOSSUM, both of them are termed as evolutionary distance matrices. However, the most important thing, PAM is only considered to be the evolutionary distance matrix for sure, whereas BLOSSUM, though it measures evolutionary relationships, the basic fundamental behind estimating these relationships is looking into the similarity between the amino acid sequences. Now, when are you actually going in for substitution matrices based on physicochemical properties? You go in for such matrices when you're studying functional constraints in protein evolution. And what do you mean by functional constraints? It means there are certain regions in the protein. If you have a protein, there are certain regions in the protein which are well conserved. All of us know such regions are very important for the protein for its functionality. So they are the amino acids that are generally present in the active site. So when you're studying about the amino acids present in the active site, you generally go in for the physicochemical properties to look at, if at all there is a change, what would be the change in the active site. And similarly, you use such matrices also to score conservative mutations. What do I mean by conservative mutations? Let's talk about this matrix here first. Now, see, alanine and alanine is an identical match. Therefore, you have given it a plus score or a positive score. However, when you are looking at alanine and isoleucine here, you are not giving it a negative score, but you still give it a positive score. The reason why we give it as positive score was already known to you previously, because I told you, even if there is a substitution, if at all there is a positive score that is given, it means that this substitution is because both of them belong to a similar group. Now, this concept here again reiterates the fact that the score is never less than 0. It is always greater than 0, and it is a positive score when there is a substitution between the amino acids that belong to the same. Now, we'll see. Alanine here, if you are looking at, is a non-polar hydrophobic amino acid. And if you are looking at isoleucine here, it is again a non-polar hydrophobic amino acid. Both of them belong to the same group. And that's the reason why, if there's a substitution from alanine to isoleucine, don't give it a negative score, but you give it a positive score. And this is what is the concept of similarity that we discussed. And similarly, if you go back and look at the example again here in this matrix, alanine and leucine, if you look at the match, again, this is given a positive score. So again, if you go back to the table that we had seen before, and if you look at this again, you have alanine over here that is hydrophobic. And then we'll go back to leucine here and see that, okay, again, even this is hydrophobic. They again belong to the same group. And that's the reason why you don't have a negative score, but you give it a positive score. And this is regarding the substitution matrix based on the physicochemical properties.